Hi class, so the focus of this lecture video will be on box plots and five number summary. But one thing I want to talk maybe a little bit more about some where we left off in the last video, about some things that I want to make clear. So let me get, so the first thing that I want to make clear is I want to make sure you understand the idea of what a population and a sample is, right? So population and a sample, right? So let's say we want to do a statistical study, right? So maybe I want to do a study where I am measuring, um, I don't know, Marian Tech student heights, right? So if I want to if I want to do a statistical study to find out about Marian Technical College student heights, then I can't simply it's not really possible for me to measure every single person, every single student, right? So, for example, we have students in the prison population. We have students spread at like 20 some high schools. And also, if I just sent out a email to all students, not everyone's going to respond to the survey, right? So statisticians agree that it's okay. We can never truly find out about all of the population, right? So what we do in statistics is we pick a sample, right? So let me draw a diagram. So imagine in this circle, this is our population, right? So in the example that I was talking about, referring to, my population in this case would be all MTC students, right? So all MT students are inside of here, right? Um, so as I was saying, we can't measure every single person in this population, right? Not everyone's gonna respond. It's really hard to track everyone down, right? It's not really um, not really a good use of our time either if we could track everyone down, right? So statistics, what we do in statistics is we take a sample, right? So maybe this group, this part of my population becomes my sample, and I take this sample, and then I can use that information to estimate for the population, right? And there's a lot more to sampling, but I won't get really into that. This class is more of a bird's eye view of some statistics stuff. We're not, that's not our 100% focus. That's maybe about 30-40% of our focus of the class. So I just want to give you some background knowledge, a little bit of background knowledge in it, so you can make sense of the class, and also so you can make sense of some things in your life, right? This class is really meant for helping you with mathematics in your life. So there are some sampling techniques to find this, and if done correctly, the sample will very closely estimate what our population would be, right? So also, if you read in the book, section 1.4, we talked about mean and standard deviation in the last video, but in the book, you would have seen something like this for mean, right? So, like this formula, x bar equals sigma x sub I all over n, right? And you also seen a formula maybe like this, SD for standard deviation. So that's the square root of the sum of x sub I minus x bar quantity squared, right? And then divided by big N minus 1, right? Alright, so I just wanted to talk about this notation a little bit. First of all, when we're talking, first of all, when we're talking about mean and standard deviation, right? So when we talk about mean and standard deviation and other variables, we use different variables depending on if we're talking about the sample or the population, right? So when we're talking about a sample mean, we use the symbol x bar, right? That's how it's read, and it's an x with a bar above it. And with standard deviation, typically we use the variable s to represent the sample standard deviation. However, our book uses SD, right? Which is perfectly fine, right? So I'll put an or there, right? So we can use S or SD, right? But then with population, for population mean, we use the letter mu, right? So Greek letter mu, and then for the population standard deviation, right? We use sigma, right? Greek letter sigma. So if we're talking about the population, it's always a Greek letter, and if it's a sample, it's not a Greek letter, right? So it's just standard alphabet, right? And you might wonder why we have to use different symbols if it's a sample or population, right? So what you want to remember is that they're not equal to each other, right? The population and sample aren't necessarily equal to each other, but the sample is used to estimate the population, right? So we have to separate the difference if we're talking about the sample mean versus the sample or the population mean, right? So another thing I want to make sure you're aware of is, if you notice in both of these equations, they use symbol the sigma, right? So this symbol is sigma, and then also x sub I is used, right? So I want to talk about what those two symbols mean, right? So sigma simply means to add, right? Find the sum, right? So like here in x bar, if you look at this notation, right, we have sigma and then x sub I, right? So x sub I, this is referring to the ith term, right? So if I have, let's say I have some data, well, let me, right? Alright, so let me write some data on the board for us to use, and I want to calculate the mean and standard deviation with you using this data set, right? So let's say this is my data set, 1, 8, 6, 9, 16, 15, 12, and 18. Right? So if I wanted to find the mean of this data set, right, the arithmetic mean, you've probably done this before, where we just add up all the terms and then divide by how many we have, right? That's what this is telling you to do, right? X bar. So we have sigma of xi all divided by big N, right? So what this is telling you to do is add up all the numbers, right? So like this number 1, we could let this be x sub 1, right? This be x2, this be x3, x4, x5, x sub 6, x sub 7, x sub 8, right? So when you see sigma x sub I, right, what this is referring to is this I is just what we call an index. It's just a subscript, so that way we can talk about the different pieces of data, right? So it's saying add up all the data, right? So in this case, I equals 1, 2, 3, so forth, right? So we would just do 1 plus 8 plus 6 plus 9 plus 15 plus 12 plus 18, and then divide by N, right? So remember, N, this is the count, right? We use big N to represent the count. So I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data, right? So we would divide by 8. Right, so you can grab your calculator and do a quick calculation. Right, so I'm getting 69 for the sum, right? So we'd have 69 in the numerator divided by 8. So if we take 69 divided by 8, I get a mean of 8.625. Right? All right, so let's calculate the standard deviation, right? So remember, the standard deviation, that equation was equal to the square root of the sum of x sub I minus x bar, right? This quantity squared, all divided by n minus 1. Right. Remember, the standard deviation, what this number represents is the average distance that the points are away from the mean, right? And you might want to, if you think about a moment, you might wonder, well, why am I dividing by n minus 1? Because, if I wanted to find the average distance, I would want to divide by n, right? I'd want to find the distance between them all, add them all up, divide by n. I don't know why we're squaring, have square root. Why do we have an n? Why do we have n minus 1, right? And the answer is, you have to remember that we're trying to take a sample of the population and do some calculations to estimate the standard deviation for the population, right? But we need this divided by n minus 1 and the way this formula is set up, because this gives us the best estimate for the population, right? If we don't have those things, typically our estimate is too high, right? All right, so to calculate this by hand, it's not quite as easy with Excel, right? So you can really appreciate using Excel. Oops, let me get rid of this. Right, but what probably the easiest way to do this is to make a table, right? So I'd probably make a table so we could have, here's x. So we have 1, 8, 6, 9, 16, 15, 12, 18, right? We already found the mean, right? So this next row, we want to calculate x minus x bar, right? And in one of your concept checks, you have to calculate the distance from the mean for every data point. So that's what this is doing, right? So I want to take 1 minus the mean, right? 8 minus the mean, and so forth, right? So we can calculate those, right? So if we take 1 minus 8.625, right, we get negative 7.625. And then next, you take 8 minus 8.625, and we get negative 0.625. Then we would take 6 away, right? 6 minus the mean. So 6 minus 8.625. And we get negative 2.625. Right? So just keep going. So I'm going to pause the video a moment, just fill these in to save some time. Alright, so I filled those in, so we've got one left to do. So 18 minus 8.625 is 9.375. Right? So, and also one thing you can notice is all the negative values are values that are to the left of the mean, where values that are bigger than the mean are positive, right, when we find the distance. So this sign indicates which is it to the left or to the right of the mean, right? So in this equation, I want to find the sum of the individual values minus the mean, right? So that would be adding up all of these figures together, right? So if I add all these, add them up in this column, right? This would be the sum of x I minus x bar, right? So let's do that. Alright, excuse me, I forgot one step here, right? We're trying to find the sum of taking the distance between, but we also have to square, right? Um, so we don't actually want to find the sum of this column quite yet, right? So what we want to do is come over here and make another column in our table. Oops. Try to make this neater here, sorry. Alright. Alright, so I want to come and make a new column where I want to take x, xi minus x bar, right? I want to square these values, right? So in other words, every number in this column here, right, I want to square. Right, so we could type that in the calculator real quick. So negative 7.625 square this. Right, so I get 58.140625. Right, so we square the next one. Negative 0.625 squared. So I get 0.390625. Negative 2 point. Right, so the next one is negative 2.625 quantity, so squared. We get 6.8890625. Right, so the next value is 0.375. So we can square that. We get 0.140625. Right, so take 7.375 and square that, and I get 54.390625. So next take 6.375 and square that, and I get 40.640625, and then 3.375 squared, so I get 11.390625, and then lastly we have 9.375 and square that. I get 87.890625, right? So now I want to sum this column, right? So this would be the sum of the xi's minus x bar quantity squared, right? Summing all of these up. So add all these up in the calculator and see what you get. Right, so 58. Um, 390625. Alright, so then 11.390625 plus 87.890625, right? So I should have all those typed in, okay? So I get a sum of 259.875, right? So we have that. And I can also find n minus 1, right? So I have 1, 2, 3, 4, 5, 6, 7, 8 data sets, right? So if n equals 8, then n minus 1 equals 7, right? So now if I plug these values in to the formula, oops, right. So we could estimate that, right? So plug that in your calculator really quick, right? So take the 259.75 divided by 7, then take the square root of that, and I get approximately, so rounding, 6.093, right, is what we'll round to, right? So that's about what I'm getting for my standard deviation. Right, so hopefully that helps make more sense of what some of these symbols mean that were presented in the text, right? So then next I want to focus on the five number summary, right? So the 5 number summary, as talked about in the text, talks about the following values. Alright, so 5 number summary. So a 5 number summary, what we're talking about is my minimum value, my first quadrant, or excuse me, quartile, right? So first quartile, right? And we use a symbol Q1 to talk about quartile 1, right? And then next is quartile 2, but that's actually the also known as the median, right? So the second quartile, or Q2, is the median, right? And then the fourth in the 5 number summary is Q3, the third quartile, and then lastly is the max, right? So what this does is separates our data, right? So the first quartile separates the bottom 25% of our data to the top 75%, right? The median, right, the second quartile splits our data from the bottom 50% and the top 50%, right? The quartile 3 separates our data from would be the bottom 75% from the top 25%, right, and so forth, right? So that's what this data does, right? So let me write down the previous data set that we had, right? So the previous data set we had was the numbers 1, 8, 6, 9, 16, 15, 12, 18, right? So I'm going to show you how to draw a box plot by hand, right? So what you'd want to start with is you'd want to sort your data, right? So sorting this data, we would put it in order from smallest to biggest, right? So we'd have 1, 6, 8, 9, 12, 15, 16, 18, right? And then you want to find the median, right? Is where you want to start with. So the median is going to be some number that splits my bottom half from my top half, right? So if we go try to find the middle, right? So there's 1, 2, 3, 4 here, 1, 2, 3, 4 numbers here. So actually, both of these values are in the middle, right? So I need to find what's the number exactly in the middle between 9 and 12, right? In order to find the median. So to do this, you average them, right? We would take 9 plus 12 divided by 2. So this gives you what, 10.5, right? So 10.5 is right in between these, right? So this is Q2, or the median. And then to find Q1, what we're going to do is find the median of our bottom half, right? So we already separated the data. So the data this way, this is the bottom half, and the data this way, right, would be the top half now. So Q1 is going to be the median of the bottom half, right? So we're only considering the numbers 1, 6, 8, and 9, right? So again, right in between here would be the middle, right? So Q1 is going to be the average of 6 and 8, right? Which would be what, 7, right? So then next to find the find Q3, right? We would want to average numbers 15 and 16 similarly, right? Find the median of the top half. So 15 plus 16 divided by 2 is going to be Q3, which comes out to be what, 15.5. Right, and of course this is my min and this is my max, right? So then to draw a box plot, right, I can just draw a number line. So we can go let's start at 1, and we'll go up by add 2 each time, right? So we'll do 1, 3, 5, 7, 9, 11, so forth. And we can stop at 19, right? Because my biggest piece of data is 18, right? That's the max. So then what I'd first do is draw a box from Q1 to Q3, right? So Q1 was at 7, right? So we would start our box here, and we go to Q3, which is 15.5. So that'd be somewhere around, whoops, doing it too far, maybe right here. Right. So this part of the box, this is referred to as the inner quartile range, or IQR, right? So this was Q1, and this was Q3. And then I'm going to draw a line in my box right where the median is, right? So the median was at, what, 10.5? So somewhere around here, right? So here's 10.5. This was the median. And then now I draw the whiskers, right? So this is a box plot, or sometimes called a box and whisker plot, right? So this is referred to as the box, and then the whiskers are these lines that go to the min, right? So our min is 1, right? So I would draw a line from 1 to my box, and then draw a line from my box to the max, which was 18, so it would be about there, right? So this is my max, and this is my min, right? So a box plot can just help us get some more descriptive statistics, help us understand about the data, right? Because when we just look at a bunch of raw data, we don't really know what the data is telling us, right? So we do these type of techniques to kind of get a sense for what the data is trying to tell us, right? All right, so that's all I have for this video. So if you have any questions, make sure you contact me.